Okay, so section 1.5, I'm going to take a look at quadratics and how we can transform them. Okay, anytime you're working with quadratics, especially when you did factoring back in like Algebra 1, okay, that's probably how it was written. ax squared plus bx plus c. Okay, where a, b, and c are real numbers. Okay, we're not dealing with imaginaries. Okay, that's what that statement says. A, b, and c are real numbers. So you could have a problem like 2x squared plus 6x minus 7. Okay, and then you would factor it or something like that. Okay, there's only one condition on A. A can't be 0. What would happen if I made A 0?
Anybody? 0.
Yeah, if you do 0 times x squared, you just wiped that out. So now you don't have a quadratic anymore. Now you have bx plus c. That's just a line. Okay, so A can't be 0. All right, so we'll take a look at the most basic parabola you can graph, y equals x squared. Okay, this is the case where you don't have a b, you don't have a c, those are both 0, and a is just 1. Okay, that's y equals x squared. All right, so let me graph that. All right, and even in the homework, we already graphed some of these kinds of shapes. Okay, so there's y equals x squared. Okay, now what I'm going to do is I'm going to change it. What I'm going to do is change all the x's to negative x's. Okay, and I want to look at the difference when I graph it. Okay, I'll leave the original. Okay, but let's put it in parentheses. Put the squared on the outside of the parentheses. Okay, and let me hit graph. What's the difference between the two things I just graphed?
Nothing.
Yeah, for this graph, there is no difference. Okay? I just changed the x's to negative x's. Okay? And on this graph, you can't really tell what happened. But let me change that 2 to a 3 so you get a different graph. And let's see if you can tell me what's happening now. Okay, that's the original x cubed. And the one in red is what happens when you change the x's to negative x's. Anybody describe what happened there? All right, so yeah, it's the one in blue is what we call an increasing function. The one in red is decreasing. How about visually? Does anybody see how the blue one and the red one are related?
They're inverse.
Yeah, they're mirror images of each other. Okay? So basically what I did there is I created a mirror image over the y-axis. But in a parabola, okay, since the y-axis is already a line of symmetry, and you find a mirror image of something that's already symmetrical, it looks the same. All right, so a parabola doesn't really show a mirror image over the y-axis because it's the same thing. Okay, when you graph a parabola, we have a point called a vertex. Okay, in the one that I drew, it was like this. So it was a low point. But if we flip the parabola over, then it can become a high point. Okay, and that's all that a vertex is. It's either the lowest point or the highest point on that curve. All right, so now what I'm going to do is I'm going to try putting a number in front of x. And I want to see what that does. Okay, so I'll graph x squared. And then I'll graph 1/3 x squared and see if we can tell the difference. Okay, so I'm going to graph x squared and just change this to 1/3 x squared. Okay, so there's the original. And there's 1/3 x squared. Okay, what did that 1/3 cause to happen? Yeah, okay, it kind of distorted it a little. You could look at it two ways. It either stretched it out horizontally, or you can imagine taking the blue one and pushing down on it, kind of compressing it. And if you compress that blue one, it would kind of squish out sideways. All right? What do you think is going to happen if instead of a 1/3, I put 2? I'm good.
It'll probably,
What do you think is going to happen this time?
pulling it out.
Yeah, what's going to happen now is
It's thinner.
it's going to look thinner, or you can think of like taking that blue one and pulling it up, kind of stretching it out vertically, and it would get skinnier. All right? So sticking a number in front causes what we call either a vertical stretch or compression or shrink. Okay, so when you plug in a number bigger than 1, that causes it to look skinnier, right? It stretches vertically. Okay, that's how we're going to say it. Vertical stretch. If you plug in a number between 0 and 1, like 1/3, 1/2, that causes it to compress vertically or shrink. Okay, in fact, I'm going to say compressed. And obviously, the more extreme you make A, the more extreme you can stretch or compress it. If you make A 100, that's really going to stretch it. Okay? If you make A like 0.01, that's really going to compress it. Okay, any questions on when a parabola stretches or compresses vertically? All right, so let's try something else. Let's try sticking a negative in front of the whole function. So it's not a negative inside parentheses squared. We're just throwing a negative in front of the whole thing. Any guesses what a negative is going to do? Nick? Yeah, it is going to flip it. Let's see how it flips it. Okay, because there's two ways you can flip, right? You can flip over the x-axis or over the y-axis. Let's graph x squared, and I'll graph negative x squared. Okay, this is different than putting the negative x in parentheses. Okay, so the one in blue, there's your original. There's your one in red. Okay, how did this one flip? Over which axis? Yeah, this was flipped vertically, right? Kind of flipped down over the x-axis.
I have a question. If that was flipped over the y-axis, wouldn't it look the same?
Yeah, that was the first one I did. Yeah, it was a mirror image over the y-axis. You couldn't tell for a parabola. You can't tell. All right, so in this case, the negative causes the graph now to open down because it was reflected over the x-axis. And that would be the same for any of those. Right? What's happening in the second and third one is two things at the same time. There's a vertical stretch or compression, and there's a reflection over the x-axis. Okay, so two things at the same time. The first graph, there is no vertical stretch or compression. It's just a reflection over the x-axis. All right, so now what I want to do is take a look at that graph, y equals negative 5x squared, and I want you to explain to me the transformations to change this into that. Okay, and let's just start with how many. Hey, how many things are happening in y equals negative 5x squared? How many different transformations? How many?
2.
Yep, there's 2. Okay, let's start with the 5. Okay, who can tell me what the 5 does?
Stretches it
Yep, which way?
vertically.
Yep, so we're going to say it's a vertical stretch. And not only do we have to say it's a vertical stretch, but tell me how much. So we say vertical stretch by a factor of 5. Okay, vertical stretch by a factor of 5. And lastly, we have the negative. Okay, what is, we just did that one. What's the negative cause to happen? Luke? Yep. So he said both things, which you have to say. So reflect, but then tell me how. Over x-axis. Okay, so there's a big difference between, I want you just to look at y2 and y3. One of those is a reflection over the x-axis. The other one is a reflection over the y-axis. It depends if you put the negative inside the function or you just throw it in front of the whole thing. Okay. So in this case, as James mentioned, y1 and y3 would look the same. You wouldn't see a difference between those two for a parabola. Okay. Okay, the order that we write transformations is important. Towards the end, I'll get to the order you should say them in. Okay. Questions on example 2? All right. All right, what do you think is happening here? So now we're not multiplying by a number or putting in a negative in front. We're subtracting 3 on the end. Yep.
And shifting where the vertex will be.
Okay, which direction is it going to shift?
Well, it depends on the sign.
All right, how about in x squared minus 3?
I think it'll go down 3.
Down 3. All right, let's try it. So I've got the original in blue and the new one in red. Okay, and sure enough, it does shift it down 3 units. Yep. Okay, so to answer the question, how do we get from y equals x squared to x minus 3 squared? So to get y equals x squared minus 3, we need to shift y equals x squared down 3. And this is an example of a vertical shift. Okay, I didn't do the other one, but any guess what's going to happen if I did x squared plus 2? It would shift it up 2. Does anybody need me to do that one? Okay. So a shift is what we call a rigid motion transformation. Okay? It does not stretch it or distort it in any way. It just takes what's there and moves it. So the way this works is pretty much common sense. Okay? Not all the transformations are what you would expect, but this one is. Okay? If you put a positive number on the end, okay? If you add a number, that's going to shift up. If you put a negative number on the end, like minus 2, that's going to shift down. Okay, and I say shift down absolute value of k units. Okay, because you wouldn't want to say like shift down negative 4 units. That doesn't make sense. Okay, if you're going to talk about shifting, just say shift down 4 or shift up 4. Down is the negative. Okay? Any questions on that? Those are vertical shifts. All right, so if we can shift a parabola vertically, up and down, what other direction do you think I can shift it? Yep, we can shift horizontally. And that's what our next example looks like. Now, this time you're going to add or subtract something to x, but you're doing it inside the function, okay? Inside the parentheses. Does anybody have a guess which way x minus 3 in parentheses squared is going to shift? Yeah?
To the left.
All right. We might think left because minus, negatives on a number line are to the left. Well, what other way could it shift? Right? So it's going to go one of those two ways. Let's try it and see. Well, I said not all the transformations are what you would expect. So x minus 3 squared. Okay, blue is the original. And the red one, that's your new one. Okay, so it did. It shifted right.
Oh, that's because you're squaring it, so it reverses the sign.
Well, not even squaring. It's going to happen in every function. Okay, we're going to learn that no matter what function you use, whether you use a squaring function, cubing function, square root.
Oh, really?
Yep, every single function, when you add something inside it, it shifts it. Adding would shift left, subtracting would shift right. Okay, so I'll write that one down. So to get y equals x minus 3 squared, you need to shift y equals x squared, right 3. And to get x plus 2 squared, you would shift left 2. So this is an example of another rigid motion transformation. Okay, we're not distorting anything. Okay, and basically if you have x minus a number, okay, what this is going to do is what we just saw in x minus 3. It shifts right. Okay, if you have x plus a number, that's going to shift to the left. Yep. So I think somebody mentioned this earlier. Once we start shifting, we're moving where the vertex is. Okay, normally the vertex is at the origin. But now we know how to shift the vertex left and right and up and down. So here are the 3 transformations we've looked at. A is your vertical stretching and compressing. H is your shifting left and right. K is your shifting up and down. If they just give you an equation, okay, and they want you to say, where is the vertex? Look at what H is. Look at what K is, and write that down. That's where the vertex will be. H, comma, K. The trick is that you look at the number after the minus sign for H. Okay, so if they give you a problem like this, y equals x plus 3 squared minus 2. You have to be very careful with H. H is the number after the minus sign. Is there a minus sign here? No. So what I would do is write it like this. Okay? Instead of thinking it as plus 3, think of it as minus 3, which is plus 3. But now you have a number after the minus sign. The number after the minus sign, negative 3. Okay, so we're gonna go through a couple of those, but just be careful when it's a plus. Okay? Always look at the number after the minus sign for H, and then K, whatever it is, it is. There's nothing tricky with the vertical. Okay? So this problem would have a vertex at negative 3, comma, negative 2.
So in the parentheses, no matter what, it's going to be like, what is h? You always have to say it's a negative number.
Yep, you got to look at the number after the minus sign. Okay, if they gave you one like this,
So if it was just -3, positive 3?
yeah.
Well,
Okay, in this case, what's the number after the minus sign?
positive.
Positive 4, right there. Look at the number after the minus sign. Okay, so if it's a plus sign, you got to be careful. If it's a minus sign, just take the number that's right after it. Okay, that's your h. And this is k. So this one has been shifted right 4, down 8. That's what my vertex is. 4, negative 8.
What happens if there is a plus sign?
If there is a plus sign, then you have to think of it as minus a minus. Okay? If there's a plus sign, it's really shifting left. That's the negative direction. Okay? It's a little tricky, but we just got to be careful. Plus moves in the negative direction.
So it's just the opposite.
Yeah, horizontal stuff, and that's how it is all year, is always the opposite. Vertical stuff is easy. Okay? There's nothing tricky about the k part. All right, so not only does the vertex move, but the line of symmetry moves as well. Here's your parabola. Here's your line of symmetry. And let's say these are your axes. When I shift this parabola, the line of symmetry goes with it. Okay, whether I shift left or I shift right. How about if I take a parabola and I shift up or down? Does that affect the line of symmetry? No, because this line really goes forever in each direction. So shifting up and down, the k value has no effect on the line of symmetry. Okay? Only thing that affects the line of symmetry is if you shift left or you shift right. And again, we're going to do a few of those. Okay, so here's an example. And I want to find just the vertex and the line of symmetry. Okay, what do I have to be careful of in this one? Right, it's a +2. So my suggestion is think of it inside the parentheses like that. It's like the opposite. Okay, so what's my h value for the vertex? -2. This has been shifted left 2, and then -3, down 3. That's your vertex. Okay, what is my line of symmetry? And is it x equals or y equals? Yep, x equals because it's vertical. And what number? Yep, -2. That's it. That's all you have to do for that kind of problem. Any questions on that, or does anybody want to see one more of the vertex and line of symmetry? So same directions. Okay, what's my vertex here? James?
8, 7.
8, 7. That's the vertex. Remember, minus shifts to the right. Okay, if you shift something to the right, that's a positive. Okay, 8, 7. And what about my line of symmetry? Good, I like the 8, but we need something else with it. X equals, right? You have to put it as an equation. X equals 8. And I can make up another one, but anybody want to see another one of those? We have another one we're going to do eventually anyway. Right, so it's always the number after the minus sign and the number at the end. All right, so let's do the same thing we did in an earlier example. I want to explain how I can get this from that. Okay, how many transformations are they doing this time to change f of x equals x squared into 5x squared plus 4? Yep, there are 2. Okay, let's start with the 5. Okay, what's the 5 doing?
The graph of parabola, right?
Which direction? Horizontal, or I mean, is it vertical? Or yeah, vertical. And is it going to stretch or compress? Stretch, right? Numbers bigger than 1, stretch. Numbers between 0 and 1, compress. So vertical stretch by a factor of 5. And what about the plus 4 at the end?
Move the graph up 4 on the y-axis.
Yep. So you can just say shift up 4 units. Just make sure you tell me the direction and how much. Up 4. Okay. Again, we're going to have an order. It's going to be very clear shortly what the order has to be. I'm kind of guiding you through the order right now. Okay. This one is going to have every transformation in it. I think that we've looked at. So it's a good one to start to look at the order. Okay, how many transformations are happening here?
4.
Yep, there are 4. Okay, remember this negative and 3 are two different transformations. Okay, and the way we're going to think about it is think like PEMDAS. Right, the first thing you would do, start inside your parentheses. Okay, so what's the minus 1 going to do?
Shift it over on the x-axis 1 to the left.
So it's going to shift it 1 unit
To the right.
to the right. Yep. So just write shift right 1 unit. Okay, now we're doing PEMDAS. We go outside the x parentheses. Okay. The next thing I have right outside is a 3. Okay, the negative is separate. Okay, what's the 3 do? How about Curtis?
I'm not sure.
Well, what's it do when you stick a number in front? I think it's the first transformation. Yeah. So how do you describe that? What would you say?
The negative front, the 3 makes the parabola vertex be higher than the ends.
Okay, so that's going to be my next one, the negative. That's going to be my third. But how about just my second one?
It elongates the parabola.
Yeah, so we have a vertical stretch by a factor of 3. Okay, so just make sure you put the word vertical in there. Okay, vertical stretch. Yep.
Because it's a negative when we compress it?
Nope, the negative is going to cause, what's the negative do? That's a flip. Okay? The only way you could have a compression is if you put a number in here like a half or 1/3, something like that.
So it has to be between 0 and 1.
The number right here has to be between 0 and 1 to compress. Yep. So that negative causes a reflection or a flip. You can say it either way. And it's going to reflect it over which axis? The x. Okay? Putting the negative in front of the whole thing reflects over the x. If I put a negative on the inside, that would have reflected over the y. Okay, but we're not doing that this time. So reflection over x-axis. And the very last thing is a plus 4. That's going to shift up 4. All right, so that basically summarizes our order that we should always follow. Okay. Always do your horizontal shifts first, followed by any vertical stretching or compressing. Then do your reflection over the x-axis. And these are actually all if necessary. You don't have to have every transformation in every problem. Okay, this one did. And then after your reflection, do your vertical shifts. Okay, technically you can switch 2 and 3. and the answer would still be correct. But just stick with this order all the time, and you'll never have a problem. Okay? Okay, any questions on that order? Okay, if one of the transformations is missing, just skip it. Just don't write it. Okay, so what's made all these problems pretty straightforward is when we look at them, we can directly see what's happening. Okay? I see the 3, the negative 1, and the +4. Okay? That's what we call standard form. Okay? It looks just like I've written right there. Well, sometimes we don't always have things in standard form. Okay? Sometimes you might have something like this. And this goes back to like the very first thing I said. Okay? When you're factoring in Algebra 1, they usually give you a problem that looks like that. Not like that. Okay? So if you have something that's written like this, it's a little harder to figure out these 4 transformations. So what we have to do is change this into standard form. And then we can do everything that we've done. Okay, so the way that you change something like this into standard form is completing the square. Okay, how many people, even if you don't remember how to do it, just remember hearing that term before, completing the square? Yeah. It's an Algebra 1 technique for solving a quadratic equation. What's nice about this technique is it takes something that's hard to figure out the transformations and turns it into exactly what we want. Okay, so the key when we're completing the square is to make sure we keep the equation balanced. If you add something on the left, make sure you also add it on the right. Okay, it might seem like, well, yeah, that's simple, but once I go through a problem, you'll see that you have to be careful with that. Okay, so this question is the same kind of question we've been doing all through the lesson. Describe all the transformations here. Okay, the problem is the equation I'm giving you is not written in standard form. So we can't really see what's the vertical stretch, what's the shift left, right, up, down, is there a reflection? We can't tell. Okay, so I'm going to complete the square, and that's how I'll remind you of how to do it. I'll just do an example rather than just writing it out. Okay, just look at an example. Okay, first step when you're completing the square is to get the equation equal to 0. Get the equation equal to your constant. Okay? So step 1 is put the constant on the other side by itself. So I have 3x squared plus 12x equals, and I just added 18 to the other side. So this, think of this right now as a 0. Okay, anytime you're solving a quadratic, remember we always set it equal to 0. So technically, I guess this would be your first step. So that's step 1. Okay, set it equal to 0, which basically you don't even have to write that step. Step 2, add the 18 to the other side. So get constant by itself.
Constant is whatever doesn't have a variable.
Yes. Yep, the constant is the thing that's constant, never can change. Okay, the variable is, it's variable, it can change. All right. The next step to complete the square is you can't have a 3 here. You have to have a 1. So does anybody remember that term when you take a number out from two things? It ends with an F. Yep. So we're going to factor out whatever number is in front of x squared. If they're being nice to us, the number you factor out will also be a factor of the number with x. If it's not, you're going to get fractions. Okay? Luckily, I can do this one nicely. What do I get if I factor a 3 out of 12? 4. Now you're not factoring it on the other side. Okay, that 18 that's on a different side. You don't touch that. So this part, the direction is to make the coefficient of x squared a 1. You don't have to write a 1. It just has to be like that. Okay, now the next step is where we actually complete the square. Okay, so far we haven't really done anything. We've just moved things around and factored. Now we're going to complete the square. So leave a little bit of space after the 4x, because you're going to add something. Leave a little bit of space after the 18. Okay, whatever I add on the left, I have to add to the right. Keep the equation balanced. Okay? So there's 2 steps to figure out the number you need to add there. And it has to do with this number. Does anybody know the 2 steps you have to do to this 4?
Divided by 2 and then square.
Yep, you're going to take half of it. And this is the b term. Okay? If you had a quadratic equation, that's b. So, as Adrian just said, take half of b. Take b and divide by 2. And then square it. Hey, Adrian, can you tell me what's half of b? 2. And then square it?
4.
So not much interesting happened there, but just a coincidence. Okay, now what did I just add on the left?
4.
Nope, I didn't add 4.
Well,
I added 12. Okay, that's the part that some people get a little tripped up on. If you factored something out, anything you put inside this parentheses is not really that number. It's that number times what's on the outside. Okay, so you really added 12 on the left. So what do I need to add on the right? 12. That's how you keep it balanced. If you add 4 on the right, you unbalance it. And now if we've completed the square correctly, this should factor very nice. And it should factor into something times something, and they have to be the same. Like x plus 6, x plus 6. X minus 8, x minus 8. Okay, something like that. Does anybody see what this factors into? X squared plus 4x plus 4? What is it? X plus 2 times x plus 2 times x plus 2. That's how that factors. X plus 2 times x plus 2. If you want to check it, FOIL it out, and you'll see that it does work.
So that's just x plus 2 squared.
Yeah, that's just x plus 2 squared. And the reason I'm going to write it like that is because that's the form we want. Okay? So this step was factor. And the last step is to put the 30 back on the other side. That equation that I just put a box around, and this original equation up here, if you graph them, they're exactly the same thing. But now I can tell you the transformations. I see 3 of them. Before, I had no idea that this was shifted down 30 units. There's really no possible way to tell by looking at the original problem. Right? So that's one of them. Can somebody tell me the first 2 transformations? Yep, so start inside the parentheses. Left 2. And lastly, that 3, what kind of stretch is that? Vertical stretch. Okay, so this part of it's not too hard, but if you're a little rusty on your Algebra 1, we might have to go over that a little bit or come talk to me. Okay, so you do need to know how to factor and complete the square. Any questions on any part of this one? Yep.
You asked me, how'd you get that 12
When you added 18 plus 12?
Why did I put a 12 here?
Yeah.
So on the left, I did what Adrian said. I added a plus 4, right? But this isn't really a plus 4 because it's tripled because of what's on the outside. Anything in those parentheses is a distributive property that applies to it. So we have to remember that. You won't always have to do that, okay? If you didn't do this step, completing the square, make x squared coefficient of 1, if it already was, you're not going to have to factor anything out, okay? But this is kind of the worst case. You have to factor something out and remember that you did. Okay, other questions on that? All right, so I think we're just about there. All right, so the last thing, which is actually very easy, is when we have a parabola, how can we quickly tell how many times it crosses the x-axis? Okay? Maybe I don't want to know where it crosses. I just want to know how many times does it cross. Okay? So quadratics can cross the x-axis 0, 1, or 2 times. Okay? 0 times would look something like this. Okay, 1 time, the graph would just come down, touch it, go right back up. And then 2 times, it would just look like this. Okay, so we're basically looking for these x values. Okay, those are the x values that when you plug them into your formula, you get 0 as the answer. Okay, those are called your x-intercepts, okay, or your zeros. Now, if you have an equation that's in this form, all you need to do is look at A, B, and C. And those 3 numbers will tell you how many times it crosses the axis. The calculation that you have to do really quick is that b squared minus 4ac. Has anybody ever seen that before as part of something else? Yeah, it's part of the quadratic formula, but we're not doing the whole thing.
It's in the square root, right?
It's the thing that's under the square root. If the thing under the square root comes out negative, okay, maybe this kind of makes sense, but if it comes out negative, you don't get any roots. Okay, if the thing under the square root, the b squared minus 4ac, comes out to exactly 0, you'd get 1 root. And if it comes out positive, you get 2 zeros. Okay, if I say 0 or I say root, they mean the same thing. Now, this doesn't tell me where they are. All it would tell me is which one of these 3 scenarios do I have? 0 times, 1 time, or does it cross 2 times? Okay, so if I just made up, let's just say x squared minus 3x plus 1. What's a in this equation? 1, b,
Negative 3.
and c? 1. So if I did b squared, that's 9 minus 4 times 1 times 1. So very quickly, I know that's 9, take away 4, which is how much? 5. 5 is greater than 0. I don't know where this is going to cross the x-axis, but I guarantee you it crosses it twice. That's all I know. Okay? So that's what that formula allows you to do. Any questions on that? So I think that's a good place to stop for today. Okay, so homework tonight, just on page 56. Okay, it's only one section. And there's not really a range of problems. I just picked random problems. I think I picked about 14 or 15 of them. So 1, 2, 7, 10, 11, 16, 18. 21, 22, 28, 33, 40, 41, 44, and 60. Okay, so we'll look at that first thing tomorrow, then we'll finish up tomorrow with section 1.6, and that'll finish chapter 1.